So the main thing I typically ask somebody when they're looking at 3D scanners is how much accuracy you need. If you're measuring something for quality control and you have a specific tolerance where something has to be within plus or minus 10th thou or something like that, then you are going to have to be a little bit more selective with your accuracy.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Gabrielle Williams from Creaform and Peel 3D, manufacturers of both industrial, high-end, as well as the enthusiast market 3D scanning products. This is a technology that has really evolved very quickly, particularly in the last 10 or 15 years. And these products have gone from absolutely out of reach and only for the mega wealthy OE manufacturers and the like, through to something that now a well-funded home enthusiast could actually afford an entry-level product. Not to mention, most of us nowadays are walking around with some form of 3D scanner in our pockets in the form of our smartphones. We talked to Gabrielle about her background, and admittedly, Gabrielle doesn't come from an automotive and motorsport background. Her interests really are in the technology around 3D scanning products, but that doesn't make this interview any less relevant. We talk about her qualifications and how she ended up working on a nuclear-powered aircraft carrier of all things, and then transferring her skill set into her current position at Creaform and then Peel 3D. We talk to Gabrielle and find out about the various technologies that are used in the different styles of 3D scanning products and why some of these can be literally hundreds of thousands of dollars, and while others can still do a really good job at the sub sort of $5,000 to $10,000 price point. We talk about what you need to be considering if you're in the market for a 3D scanner and what the different metrics of these scanners actually mean. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes, and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome to the podcast, Gabrielle. Thanks for joining us today. And usually I always start these interviews off by finding out a little bit about how our guests got involved in cars and the motorsport industry. Of course, as I mentioned in our introduction, you're not specifically involved in motorsport yourself, so I'm going to change this question around a little bit. How about we start by finding out about your education and background, which sort of led you to working for Peel 3D?
Sure. Well, I grew up in Huntington Beach, California. Then I joined the Navy, actually, after high school. Within the Navy, I realized I was actually kind of smart. I was a nuclear operator.
Okay.
So I took a few tests. I found out I was kind of smart. They told me to go to the nuclear program. I joined there. And then that's when I realized, after I graduated from nuclear power school, that I could pretty much do anything I wanted, kind of thing, like as long as I put my mind to it, which is a big thing to realize as a an 18-year-old kid kind of thing.
Definitely. I feel like we need to just back up a step here. I mean, I don't speak to anyone actually who's involved in nuclear power generation. I mean, what does this position involve? What are you actually doing?
So you know how a car works, and I know how a nuclear aircraft carrier works, basically. I might not be able to tell you how a car runs, all the ins and outs and all the different systems, but I totally know all the systems, or at least at one point I did, knew all the systems on how a ship runs. And so that involves nuclear energy and nuclear power, and that's what makes these nuclear aircraft carriers move.
Okay, all right. I mean, I think most of us, when we think of the nuclear power generation industry, has sort of flashbacks to Homer Simpson, creating some kind of disaster. So it's good to know it's a little bit different to that.
Yes, it's a positive side of things. So anyways, after I graduated from nuclear power school and went on to the Navy for a few years there, after I got out, I decided to do my mechanical engineering degree. So I went to UC Irvine, zat, and I went and graduated from there. And then after that, I was starting to look for a job. And I went back to UC Irvine's career fair one day. And they had a company called Creaform that was looking for somebody that was able to travel, speak Spanish, because they also wanted us to give trainings in Spanish and English. And I speak fluent Spanish. My family is Ecuadorian. So I was able to join with them. They said they'd train me. So I learned all about 3D scanning, something that I really didn't know much about back then in 2016. And yeah, actually 2017. And then I joined and I traveled a lot around the Western Hemisphere with Creaform and learned all about 3D scanning and taught all about it, did trade shows and fun stuff like that.
Okay, so basically straight out of a mechanical engineering degree, first job essentially, straight to where we are now. I'm just interested, the mechanical engineering degree, and I mean, I would say probably more than 50% of our guests so far on the podcast have had a mechanical engineering degree. As I've often talked about, this degree is actually quite a wide-ranging degree. It covers a huge amount of ground. Was that sort of an essential stepping point to your role with Creaform now?
Not really. Well, actually, so they did need a mechanical engineer specifically, if that's the question you're asking.
Yeah.
Yeah, so they were looking for somebody that has a mechanical engineering degree because I was going to oftentimes be training mechanical engineers as well. So I needed to be able to speak their language and also understand how the technology worked, like the basics of the technology. On top of that, we were also going to be doing things like bug testing and reporting and things like that as well. So they wanted to make sure we were backed up with the knowledge.
Sure. All right, so let's talk a little bit about Creaform and Peel 3D, how, first of all, those two companies fit together, and let's just sort of get a little bit of a 30,000-foot view of the business.
Yeah, so Creaform just celebrated its 20-year anniversary, I think last year maybe, and around 2017, there was a scanner that we had that was on the market, and we started, Creaform's always innovating. So, of course, we came out with a new scanner and new technology, and we were able to lower the cost of other scanners. Well, one of the scanners that we had, we were kind of thinking, well, instead of selling it at a really low cost point, and having our account managers having to do all this extra work for this, let's just sell it online, kind of let it sell itself to the entry level market and see where it goes. It's kind of like a side project, Peel was. And so we did start off with selling one of our scanners. We rebranded it as the Peel. And it did really well to the point that we thought, okay, well, now let's invest some R&D time and money into creating the next step of this Peel scanner. So that's where the Peel 3 comes in. So the Peel 3 is its own scanner. It never existed before. And it's got all the backing from Creaform's R&D team. And yeah, it's been a really great success. That one came out in October of 2022.
Okay. So am I right in sort of joining the dots here that Creaform is producing sort of more industry spec products at a higher price point, and Peel is more the, I wouldn't say necessarily entry level or enthusiast market, but selling products similar but at a lower price point?
Right, more for like the prosumer is what we call it. So like the professional consumer, maybe not somebody that's going to be like have the funds of Boeing or NASA, but somebody that, has a mom and pop auto body shop, and, they're thinking about improving the speed at which that they can produce, do their projects. and they're kind of getting tired of using a measuring tape and gauges, and they can really get a lot farther with a 3D scanner.
Yeah, of course. All right, so Creaform and Peel separated from each other in locality, or is this all out of the same facility?
It's all in the same location, and we are a global company, Creaform and Peel. Yeah, so the same people that will be working at Peel are also located in the HQ in the Creaform's building.
Okay, and can you give us an idea of how many staff are on board between the two?
Well, last I checked, it's been a while, but Creaform I think is somewhere around 600 or 700 people. And then Peel, if we don't count our distributors globally, I might say somewhere around 10 people.
Okay, all right. Significantly smaller operation to the Creaform operation. Okay, if we focus purely on Peel for a moment, can you give us a rundown on products and services? You've mentioned the Peel 3. I think we've actually just taken delivery of one of those, which Connor's going to be using in our upcoming 3D scanning course, just to put it through its paces. But yeah, how many products are on offer? Do you do any consulting work, or is it purely just a case of here is the product?
Yeah, as far as consulting goes, we don't really do like projects, I guess, for other people. If anybody ever wants to do a project within Creaform or Peel, as long as they do have some kind of a Peel or a Creaform equipment, then they can contact Creaform and have them do a project for them, like a service for them. But this is mostly just to make sure that our customers are happy, basically, to make sure we can back them up. But as far as different products go, we have the Peel 1, Peel 2, Peel 2S, and the Peel 3. So the Peel 1 kind of came before anything else, and I think we still even have a few of those left in the available. I think somebody said we might have maybe like 19 of those or so, something like that. And then we do have some Peel 2s and some Peel 2S is still available, but we have very few of those. I mean, by the time this podcast airs, we might not have any left.
We actually got our start with Peel with a Peel 2S. I think we ended up finding one sort of locally that was secondhand and at an affordable price point for us. And I do remember at the time sort of thinking, do we really need this? And honestly, that scanner is almost in use every day of the week. And it's been an eye-opener for me coming from a non-3D modeling and CAD background, just seeing how many uses there are for this product in our day-to-day work. So it's definitely opened my eyes. We'll talk about the differences between these products a little bit later on, so we don't need to worry about that too much right now. In terms of getting users up to speed with the product though, what's the sort of the training process or training options available for them?
Yeah, so when you purchase the Peel 3, let's say that's the most recent version of the scanner that we have. It comes with training material so you can train yourself. And even in the software, as you hover over little icons, it'll show up a video showing you what that means or what that does. And then on top of that, let's say you've already gone through and trained yourself as much as you want, and you really have just a few more questions. Maybe you think, okay, I can just ask some extra questions. You can always send us an email. But if it's something that requires maybe something like 2 hours, we can also sell a little 2-hour session for training as well.
Okay. So essentially, there are options for people to get up to speed with what is a fairly technical product. I like that intuitive approach where, for the most part, people are going to be able to self-train, and I guess from Peel's perspective as well, that's going to cut down on a lot of ticket inquiries on how do I do this? Why doesn't this work?
Right.
What's this button for?
Exactly.
All right, let's talk about the industries that 3D scanning is also made headways into. I mean, obviously, we're pretty selfish and we come at this purely from an automotive and motorsport direction, but obviously there's far-reaching applications for this. Can you give us some examples?
Sure. Yeah, so a lot of the times when you're doing automotive type of things and you're doing things with 3D scanning, the main reasons somebody might want a 3D scan is because you're either going to be reverse engineering something, in other words, scanning it and then creating something in CAD, whether it's a part that just matches up to it, or you want to make a replica of the part because maybe it's an old broken piece that you can no longer purchase. That would be the reverse engineering side of things. Then there's also quality control. So that would be more like you have a part and you just want to check to make sure that it is exactly the way it should be. Well, if you have the original CAD, the computer aided design of this part, then you can just compare that CAD with that scan, basically overlay it on the screen. And then from there, you can see what passes or fails according to your tolerances. So if you say, okay, the surfaces have to be within, I don't know, 10 thou or something of the surfaces between the CAD and the scan, then you can see a color map and you can see what is all in the green and what's outside of that.
Sure. So this is something that would be useful in mass production, for example, basically checking all of the parts coming off a production line and making sure that every single one of them meets the criteria in terms of tolerance.
Right, exactly. And it wouldn't even necessarily have to be every single one of them. Somebody might just choose every 100 parts to make sure that the stamping machine is still stamping the way it should be and they're not, having scrap parts afterwards.
Yeah, it makes sense. Obviously, machines wear, so over time, tolerances can sort of creep outside of spec. This is obviously something that's sort of probably not applicable at an enthusiast level, more at a manufacturing level. But is this a manual process? Does someone physically have to go and remove the part from the production line and then physically hand scan it? It's not an automated process?
Yeah, so that also depends on what level of scanner you choose, because you could also choose to have a robot scanner. So with Creaform, we have something called the Cube-R. And that one is really just this giant box that has a scanner inside of it. It has cameras and everything. And you put the part on the little rotary table. It spins the way it's supposed to spin. It scans the way it's supposed to scan. And the programming is really easy because you can even just basically draw lines on the CAD on your program to tell the robot where it should be moving while it's scanning.
All right. Fair enough. Okay. So the other use you mentioned there is reverse engineering. So as you mentioned there, maybe you want to reproduce a part and modify it, or maybe something is no longer available, as you also mentioned. The process for this, I'm guessing, also requires more accuracy in the scan. Obviously, if we've got inaccuracies there, the dimensional tolerance is not going to be necessarily good enough to reproduce that part. Is that a concern?
Right. So when it comes to whether, the accuracy, you'll usually need more accuracy in quality control than in reverse engineering. But in reverse engineering, depending on what you want it to match up to, yes, of course, you're going to need more accuracy. So in the case of the PL3, for example, we have an accuracy of 4 thou. So that's like more than enough for a lot of people doing reverse engineering. And it comes at a very nice price compared to other scanners. Yeah.
Sure. Can you give us an indication what the price point of that product is?
Of the PL3?
Yeah.
Oh, okay, sure. So I don't always remember the exact number, but according to the website last I checked, I think it was 8,700 around there for the scanner itself.
Okay, so that we're talking USD. I mean, obviously, it's not sort of walking around money. It's a fairly sizable investment, but still, these have come down dramatically just in the time we've been involved with the 3D modeling and scanning process. So it's suffice to say, and we'll talk more to this later, that price point is going to continue to come down. Correct?
Of course, yes, exactly. Because back in 2017, when the Peel, group just started, we had the scanner that came out, that was the Peel 2. And at that, right before we decided to sell it online, basically let it sell itself kind of thing, that used to be about $20,000 scanner. And then it went down to about $10,000 or so. And then now an even better scanner, which is the Peel 3, is around that price point as well.
Yeah. So obviously exciting times for us in the enthusiast market where, probably not too many of us are likely to be shelling out 20,000 USD just for a scanner. Now, another use of 3D scanning is scan-based design, or I think as you refer to it as scan to CAD. Can you give us a little insight into what this means? How is this used?
Sure. So a lot of the times when you have free-form types of bodies, it's not as simple to take a measuring tape and measure something, or to kind of understand what the shape should be. It might be something that kind of looks like a cylinder or might be a cone, but it's also changing shapes along the surface. So something like that, a 3D scanner would be ideal to use. So you can scan the item, and then with that, you can create an STL, or if you need to, you can export a step or an IGES file. And then that's the surface that you would really be using when you are creating your CAD file. So there's lots of reasons you might do this. There might be things like you are scanning a vehicle entirely because you want to make a 3D print of it. So instead of like drawing something on CAD, drawing a car in CAD, you can just scan a car and then scale it down, and then you can 3D print it. So that's the most simple version of what we're doing here. But maybe something would be where you're like kind of creating a new part to attach to an existing part. So this is where like a lot of aftermarket items can be coming from. So they'll be scanning maybe the bottom of your vehicle inside of the interior, and then you're going to be able to make the perfect fitting floor mats. Or you might scan a vehicle and make protective films or dashboard covers or caliper covers for your brakes, all kinds of things. Even just like converting the interior of a van into a camper or into like a medical van that can, later on just go around and collect blood donations or, distribute vaccines and things like that. So a lot of cool things there.
Yeah. A couple of real simple examples of this scan-based design would be a company maybe making a body kit, and this is exactly what's happening these days. They'll start with the base car, scan the bodywork so that they know exactly the shape of the fenders, the guards, etc., and then they can build their body kit in 3D modeling software. And when it's produced, they're going to be able to guarantee essentially the fitment of those parts is perfect. And I mean, if we look back at the body kit industry 15 years ago, even 10 years ago probably, you were getting some really questionable fitment, and often you were ending up spending as much with the body shop getting that fit perfected as you would on the base body kit. Another one would be the development of maybe an intake manifold or an exhaust manifold for a turbocharged car. Someone making a turbo kit, for example, might want to start by removing the existing exhaust manifold turbocharger and then scan the engine bay. What this means is they've got the dimensions of where everything is in 3D space for the exhaust flange for the cylinder head, but also importantly, they can guarantee clearance around all of the other parts in the engine bay, meaning that you can design everything in CAD, and when it comes to actually manufacturing the part, it's just going to fit. There's not going to be any surprises. And of course, when you're working on parts like that, those surprises can be pretty expensive. To give another example, I mentioned that we've been using the PL2S pretty extensively, and that was so useful when we went through the process of designing and building a custom chromoly subframe for the front of our Honda CRX. So the entire engine bay, the entirety of the engine bay and the underside of the chassis rails was all scanned into CAD, and then Connor basically could then design a chromoly subframe that would mount to the correct places, clear the engine and the gearbox, and also, quite importantly, mount to the steering rack and know that everything was going to be perfect. There was no guesswork, and then when it came to actually making the part, unsurprisingly, it fits perfectly. So, big advocate for where this technology can be used. Now, I think it's probably a good time to actually talk a little bit about the technology itself. So, what 3D scanning is and how it works. Are you able to give us a bit of insight into the different technologies available, or at least what Creaform and Peel are using?
Yeah, so there's different types of light sources that would be coming from different types of scanners. So you have things like structured white light. So we have that with the GoScan Spark with Creaform. There's the blue laser light. And before our technology with the blue laser light, we used to use red laser. But blue laser can really scan a lot more shinier types of parts. So that can be really beneficial when you're scanning things like chrome and things like that. The Peel itself is an infrared V cell type of light. And then when it comes down to like how the scanner itself works, there's two things that could help it track. There's the positioning targets, which aren't always necessary for the PL3 specifically, depending on whether there's a lot of different geometries that the PL scanner is seeing. It's a lot of the times able just to track based off of the changing shapes that it's looking at and put it all together. But if you're scanning something that's more common shaped, in other words, like something that's flat or something that has the same pattern over and over again, then you would need to put a few stickers on there and then be able to scan. And what those stickers do is it basically allows for the scanner to kind of have an idea of what it's looking at, what it's already seen, and be able to snap back to that and know, okay, I've already seen this before because I've already seen this pattern of a few stickers in the same type of constellation, if you will.
Okay.
Then another way that it does it too is basically the light that it's portraying onto the surface. It's putting on like a pattern of light onto that surface. And then depending on how the cameras and the scanner see that light pattern deform, it's figuring out, okay, the surface is curving upwards in this direction or downwards in this direction.
Okay. So, reading between the lines there, the technology can have problems with very reflective surfaces and also with continuous flat surfaces or something that's got a repeating pattern. So it really needs that constant change in surface finish or surface shape in order to really know where it is and be able to track correctly. Is that correct?
Right. So when it comes down to the shiny stuff, I've been actually kind of surprised at how well Peel 3 does with shinier materials. It's not really supposed to do it for extremely shiny, so it might have a limitation there. But if you do have a limitation and you're scanning with that scanner, you can always put a white powder on top of the part and then scan with in that way. You're always going to have to do that if you have something transparent also, no matter what the scanner is, since light was going to just shine right through the part and it's not going to bounce back into the cameras. That's the reason you're going to need a powder anyway. So there's ways to get around that too, because some places you might not want to be able to, you might not be able to put that powder on the part. Maybe you're going to a car dealership and you just want to get a specific thing from the car dealership and they've allowed you to be on the lot and scan something. Sometimes, a lot of the times, they're not going to want you to put spray on their nice new Porsche, of course. So there's options. There's actually a scanning spray out there called ASUB. It's spelled AESUB. And what they do is you can spray powder on the part and it kind of just sublimates. So in other words, it's the solid and then it evaporates after a while. So depending on the spray that you purchase, I think it evaporates within 4 hours, within 24 hours or something like that. It's a little bit more pricey, of course, than a regular just Magnaflux type of spray, but it is great for when you're not able to clean the part afterwards.
Yeah, that makes a lot of sense. I mean, one of my pet hates with the tracking targets is, at least in our workshop, it's kind of a one-way street with them. The boys are very quick to apply these tracking dots or targets, and they absolutely never remove them. And the number of times I'll sort of jump in a car, I'm like, why is it covered in these damn dots? Could we just finish the damn job and remove them? So something that's able to be sprayed on and sublimates and doesn't actually need any cleanup afterwards might be a good idea. In terms of the differences in results between the spray and the tracking dots, is it sort of a coin toss between them?
So I usually just start scanning and see what happens. If it's, having a hard time tracking, then I'll put a few stickers on there. And like you were mentioning, if it's a nice car and you don't want to have stickers everywhere and have to remove them afterwards, you can also put some kind of electrical tape or something that's easily removable, something that the car dealership won't be mad about, of course. And you can just put some positioning targets on top of that tape. Of course, you're going to have to make sure it's not in a straight line, so you'll probably have to put a few pieces of tape around. But that's a nice way of getting around it with car dealerships.
Yeah, okay. In terms of the actual process of scanning and knowing when the scanner is having problems tracking and needs these tracking targets or the spray or whatever, what are the giveaways here? And this is coming from me, who has watched this process being done, but I've never actually done it myself.
Yeah, so if, I don't know, it's maybe a size of 1 foot by 1 foot, and really the surface is very constant, very continuous, I'm definitely going to have to put some stickers on there. So something like the hood of a car, or just a flat surface on a Jeep, you're going to have to put some stickers on there, and maybe 3 or 4 would be okay. But if everything is pretty much the same smoothness, you're probably going to have to put a few more on there. And then, if it comes to shiny material, I always just start scanning, try to scan the shiniest thing and see what I need from there.
Sorry, and what does the software actually do or sort of prompt you when it's having trouble? How is this noticeable to you while you're doing the scan?
Yeah, so if it's having a hard time with the positioning targets and it's not seeing enough, for example, that means it's going to be losing tracking. In other words, you're scanning and you might have started scanning a little piece of it, but as you move away, it kind of just doesn't scan more. That's because it doesn't know where it is in relation to what it has already seen. So by just stopping the scan, putting a few stickers again, and then starting from where you were, or at least from the last view that it saw, then you can continue scanning from there. So that's one of the nice things about the scanner too. You can kind of just pause and pick it back up.
Yeah, yeah, sure. And essentially, it doesn't come up with a big flashing red message saying, "Hey, I don't know where I am anymore." It's on you to figure out. Well, I've moved the scanner, but it's not actually continuing to scan. It's a little confused and lost.
Right. And even so, there's also like a little vibration that it does to let you know, like, hey, something's going on. Maybe pay attention to the screen, or maybe you're a little too close or too far. It also tells you when you're not scanning if you're going to be like 1 inch away from the part. So you have to be around 12 inches, 15 inches or so. You have like some give there.
All right. I just wanted to take a moment out of our conversation with Gabriella here and talk about a course that's going to be perfect for those of you who are enjoying this episode and want to learn more about 3D scanning. And that, of course, is our practical 3D scanning course. Normally valued at $179 US. You can use the coupon code PEEL50. It'll take $50 off the price, bring it down to just $129 US. Traditionally, 3D scanning has been an incredibly expensive industry, meaning that it's been outside the scope of what we as home enthusiasts are likely to be able to utilize. However, that has changed rapidly, and now there are a range of 3D scanners at or around the $1,000 US mark. Even the cell phone that you've got in your pocket probably can do some basic scans. This course will teach you everything you need to know about 3D scanners, how to choose a scanner that's going to be suitable for your project, and then importantly, how to use it. Particularly, we talk about the fundamental knowledge of 3D scanning, such as what 3D scanning is, the various scanner metrics we can use to compare scanners, and the difference in the different technologies. Also, we talk about the mesh files that are produced as a result of 3D scanning. We then move into some of the practical skills, such as scanner and software parameters, calibration of your scanner, tracking and positioning targets, and how to deal with troublesome surfaces and objects. We do cover smartphone 3D scanning, where these can be used, how to utilize it, and what it is and isn't suitable for. We then move into one of the more common uses of 3D scanning, which is reverse engineering in CAD. Basically, scanning a component that we either can't get anymore or something we want to modify. We look at how this is done, how to transfer our scan to CAD, how to edit the mesh file in CAD, and then how to extract entities from our scan. We also cover scan-based design. So this is where we are designing a new component based on scan data. For example, this might be the process of making a brake caliper bracket based on a scan of a brake caliper, a rotor, and the hub or upright, making something that's going to fit all of those together. As usual, we include a step-by-step process that you can utilize for your own 3D scans. This is a 4-step process. We cover preparation, scanning, post-processing, and then setup in CAD. As I mentioned, the course is normally $179 US. Use that coupon code PEEL50 to get $50 off, bring it down to just $129 US. You are still protected by our 60-day no questions asked money back guarantee. So if you purchase and for any reason at all you decide it's not right for you, let us know and we will give you a full refund of the purchase price. There are also payment plan options that you can use at the checkout to bring that price down into weekly payments, making it a little bit easier to stomach. Let's get back to our chat with Gabriella now. All right. Now, in terms of the range of scanners on the market, obviously they all come in at different price points with different feature sets. I'm just interested if you could list some of the sort of key metrics, I guess, or performance indicators for scanners. What are the things that we're going to be looking at that we need to understand in order to choose the scanner that's going to fit our particular application and budget?
Yeah. So the main thing I typically ask somebody when they're looking at scanning at 3D scanners is, okay, so what kind of resolution do you need? In other words, how much detail do you need when you're scanning your part? If you're going to be scanning like a little D&D miniature, you're going to want to have as much resolution as you possibly can. So that would be something like 0.1 millimeter resolution would be great for something like of that size. So that would be something on the Creaform side of things. If you're looking for something that you're scanning, maybe just like a cell phone case or like a hand or a face or a shoe, or just bigger things as well. Like you can scan like surfboards or even boats if you are willing to be okay with the accuracy. Then you can go ahead and do something like a Peel 3. So that's the next thing too, the accuracy. It depends on how much accuracy you need. If you're measuring something for quality control and you have a specific tolerance where something has to be within plus or minus, I don't know, 10th thou or something like that, then you are going to have to be a little bit more selective with your accuracy. If you are doing something like reverse engineering, then you can go with something with less accuracy. So in that case, for us, the accuracy is 25 microns per meter of what you're scanning. So if it's scanning a larger part, you multiply the number of meters that you have by 0.25 millimeters, and that's what your accuracy would be there.
Okay. Just while you were talking about that, just something that popped into my mind here for the reverse engineering side of things, because obviously as we demand tighter tolerances with our accuracy on a scanner, the price point understandably is going to go up. And that could be seen, I guess, as a limitation when you're reverse engineering parts. But what I wanted to point out here is that once we've got that 3D scan into our CAD software and we've basically turned it into something we can work with, we can still go ahead and use a micrometer to take more accurate measurements on a particular dimensional surface and then use that to improve the accuracy of our model in CAD, correct?
Well, the thing about the micrometer, it's also prone to human error also. So you're going to be you're going to be using the micrometer, and then you might not be getting the most wide angle or the most deep crevice between two spaces. So actually, I would say that if you want to, you can also use the micrometer just so you can verify for yourself. But we have had, for example, people out in the field of pipeline checking. They'll use a handy scan, and they'll be checking a pipeline out in the oil. I'm not really sure the terminology, but out in the oil fields, I guess you could say. And you're scanning these pipes, and there's a certain amount of corrosion that you're allowed to have for these pipes for safety checks, right? And somebody, used to, like before they use the handy scan, they would use these depth gauges, right? And so these gauges would kind of tell you like where it's deeper or less deep. And then what they would do is when they're a lot of the times in the training, they would be scanning with the handy scan, and then they'd say, "Oh, okay, well, according to this handy scan, this is the deepest point," but that's not true because I measured it and it's over here. But then they check it manually and they're like, "Oh, actually,
It's
the
right.
handy scan's right."
How about that?
Yeah.
All right. Trust the process, trust the technology. It's probably better than the average micrometer user. And I mean, you're absolutely right. The micrometer, I mean, it can be an incredibly accurate tool, but it does need to be understood in order to be used correctly. So incorrectly used, and I talk about this in our engine building courses, and the specific example here, getting a little bit off track, but measuring bearing clearances between our crankshaft and our main bearing journals, or our connecting rods and our big end journals. In a professional engine workshop or race engine builder, they're going to use a micrometer, but I mean, they're using a micrometer every day of the week, multiple times a day. So they're obviously up to speed on how to use that to get accurate readings. My process here, I think, for the average home enthusiast is that using an alternative product called Plastigauge, which has kind of got a bit of a checkered reputation, that is probably for most enthusiasts going to give a better result because there's simply just less room for human error to creep in when you're using that product. So yeah, I'm a little bit off track here, but we'll get this back. So that resolution accuracy, obviously that's important. The other thing that I think we've noticed with going from the Peel 2S that we've been using to the new Peel 3, which I think only actually got unpackaged in the workshop yesterday. I don't think the guys have actually had a chance to power it up and get into it. But from what I understand, the 2S, the field of view, sort of exactly what you'd expect from that terminology, what it can actually see of the part you're scanning is quite dramatically reduced compared to the likes of the Peel 3. So what's that field of view mean, and what is the effect of field of view on the scanning process and speed of scan?
Yeah, so the Peel 3 has a much larger field of view, which just means that it can see more at any given moment. And the Peel 2S, since it's made for smaller parts, it can only see a smaller view of window. So you're really going to be scanning small parts with tighter details with the Peel 2S. But the Peel 3 is really nice in that it can also scan smaller parts and have that better detail as well. So Peel 3 is almost kind of like a combination of the Peel 2 and the Peel 2S, which Peel 2 was for larger parts, Peel 2S was for smaller parts.
But now with the improved technology and the PL3, kind of no real downsides over the 2S.
Right, exactly. Yeah, it beats the 2S in every measure.
I mean, that's what we kind of found as well, using that 2S, great for small parts or small scans. But, once you start wanting to scan an entire engine or an entire engine bay, I mean, it's absolutely doable, but it becomes a pretty laborious process because you're only seeing such a small field of view with that particular product.
Right.
As I understand it, frame rate's another consideration with scanometrics.
Yeah, so frame rate for as far as the Peel 3 goes, it takes in a certain amount of measurements per second. So this one's going to be at 1.25 million measurements per second, which means that as long as you have that scanner shining onto your surface, it's collecting all these data points every single second. Now, it might not necessarily need all of that because maybe you've already collected enough data points and it's just still continuing to scan more. But it's super fast. So that really means that you can just start the scanner and then just like move on the surface and it's collecting all you need. Based off of those points, then it's able to create the mesh.
I'm just assuming here that this is going to create a larger physical file than the likes of the 2S. Is that correct? Or when you've actually scanned the entire product, does it sort of come out the same size?
Right. So the 2S is probably going to be a bit smaller since it's a little bit slower. I don't remember what the value was. I want to say it was maybe 480,000 measurements per second. So about a third of what the Peel 3 is. So because it was scanning a bit slower, it was collecting, the data that it needed, but then you would probably stay there a little bit longer trying to collect everything you needed. And then at the end of it, you probably have the file size that you need. Whereas the Peel 3, you're scanning so fast that you might be, if you end up keeping the scanner on and you're just talking to Joe Schmo and talking about, what you did last weekend and you have the scanner continuously on, then yes, the file size is going to be much, much larger than you need it to be. So yeah, it's good to pay attention to what you're scanning and looking at your screen to know when you're done, because you don't really need to scan for too long since it's such a fast scanner.
All right, so a little common sense and just understanding the processes sounds like it is what's required there. Now, if we kind of try and give some guidance or advice to our listeners, and let's move this maybe away from just solely Peel. If someone was in the market for a 3D scanner, before they went to the likes of Peel or maybe one of your competitors, what do they need to have an understanding of so that they can ask the right questions and get a scanner that's going to suit their specific application?
Yeah, so the main important things would be, what size of parts are you going to be scanning? Is it going to be small parts? Is it going to be large parts? If you need something like to scan an entire building, that's a whole nother ballgame. So that's other types of scanners. But if you're scanning little tiny parts, you need to know how much detail you need. You need to know what size of, the detail would be. So like, let's say the smallest detail would be a 3 millimeter sized hole. Then you need to have an accuracy that's about a sixth of that. Then let's say you need to know if you want to scan in color or not. So maybe you're scanning for artistic reasons. Maybe you want to make sure you're able to get some decals from your vehicle that you're scanning. That's important as well. What else? And then, of course, budget. So budget is the most important thing for many people. So you need to make sure it's at a decent price point for what you're looking for. But yeah, I think that's the main thing.
It's probably a reasonably decent list that people can take on board. Okay, so the scanner is not the only part of this process. We still actually have to connect the scanner to a PC in order to do the scanning and then save the file. Am I right in assuming that the PC specification is going to need to be reasonably powerful in order to cope with the scan?
So unfortunately, I'm not a computer guru, but I do know the minimum specifications for our computer, for a Peel 3 specifically. So those you can find on our website, but to give you an idea, on our website, the recommended specifications would be things like a good graphics card. So a minimum of like an NVIDIA RTX 3070 is what's listed on our site, with 8 gigabytes of VRAM. And then memory, a minimum of 32 gigabytes. I personally have a 64 because I also run Creaform scanners as well.
So the Creaform, because they're a higher spec product, require a little bit more processing capability. Is that kind of it?
Right. It's also recommended, to have higher stuff too. But I mean, if you're going to be purchasing a nice, scanner, then we always recommend to get a really good computer as well, so that you're just always scanning even faster than, you're not limiting yourself by your computer.
Definitely, yeah. I've mentioned this before as well. If you really need a justification to go down this path, the same specifications for your PC that make it nicely suitable for 3D scanning are also going to make it the ideal candidate for a home simulator. So, if you want to do racing car simulation using the likes of iRacing or Assetto Corsa, you're going to be absolutely set with the same PC that you can use for your scanning. So there you go, two birds with one stone. I think we'll call that. All right, so I think there's a disconnect here as well, that most people assume that we wave this magic wand over our car part that produces a scan, and then voila, we bring that into Fusion or SolidWorks or whatever your personal preference in 3D modeling software is, and straight away we've got something we can work with. Can you tell us where that disconnect is and what the reality of that situation is? What is required to actually work with the mesh file that is produced?
Yeah, so when you're scanning and you just have only the scanner, basically no other software at all, what the software that comes with the scanner is going to produce for you is going to be an STL or a scan file. And that's really just a bunch of tiny, tiny triangles all put together that eventually make up an entire surface of the thing that you've scanned. And that's called an STL. It stands for stereolithography. Now, if you are going to be wanting to create something in Fusion 360, for example, Fusion 360 would have a hard time just taking straight up exactly what you scanned and putting it there. It would bog down the system, and it would just take a very long time to just even move around in Fusion. So we also have an additional software called Peel.cad, and that one allows you to do a lot of different things to the mesh, where you can decimate the file. In other words, make the triangles a lot larger on the flatter surfaces where you don't need as much detail. And then you can still keep the smaller triangles where you do need the detail. And then you can do other things like filling in holes, cleaning the mesh. But on top of that, the main cool thing about Peel.cad is using Peel.cad, you can create perfect features, shapes, or entities, if you will, to represent the mesh, the scan that you've made. And these items are things like planes or circles, points, lines, spheres, cross sections. And then these cross sections and so on, you can export these perfect items and send them over to Fusion 360 or SolidWorks or Inventor or whatever you have. And there's even a button that says transfer to these items that I've just mentioned. And within the software of your CAD creation software, you are sending all these items over so you can start building your Fusion 360 from there. You're basically sending a skeleton of your part over to Fusion 360 so you can continue building. Another nice thing too about Peel.cad is it has really great alignment features. So you can say, okay, make a plane right down the middle of my car body here, and then take this pipe center line. I'll use that as my y-axis, and so on. So that way you can align it in a way that when you're building in Fusion 360, you're starting off from the right starting point, whatever you choose that to be. So you have a good origin, and you can just start building from there. You can have your pipe center line that you can use as a loft later on in Fusion 360, and you have cylinders that you can build. And you're basically taking this imperfect part, because there's going to be scratches and dents in your vehicle possibly, and then you are able to create something that is a lot smoother and more easily used in Fusion 360 or your other CAD software. There's even an option for automatic surface. That's what it's called. So that tool, automatic surface, is you basically highlight a surface, and most of the time you're going to be highlighting something that's contouring, kind of like an organic shape. And you say, create this auto surface, maybe put, 500 patches, or you can choose 10,000 patches, whatever you want. And then once it makes that surface, that is also able to be sent over to your CAD development software. And then whenever you're building something, you can say, okay, I want this part or this sketch to go up to this surface. And then now you have that nice free-flowing surface in your CAD development software.
Okay. All right, let's dig into that in a little bit more detail. Interesting that you just mentioned about that automatic method. If we're manually working in peel.cad and producing something that we can export out to Fusion, I mean, obviously, I guess this is going to depend on the complexity of the scan that we've created, but I mean, how much heavy lifting for the user is involved? How time-consuming is this process?
It's extremely quick. It depends on the complicated part or the simplicity of the part. So if it's something very simple, it'll take you just a few minutes to do, especially if you already have the Fusion 360 skills in your back pocket. But if it's something that's going to have a lot of more intricate details, then yeah, you're going to have to spend a little bit more time. But it's really as simple as like, and I'll go at the speed that it takes to make it. So I click on sphere, I move the part, I click on the surface of the sphere, it now makes a sphere. Then I click on plane, I click on the plane surface, I click on the surface, and then now it's a plane. It's as fast as that. And you can even give it like restrictions too. So you can say all of these cylinders need to be in the same direction. In other words, the axes all have to be parallel.
Yeah, okay. Oh, that makes sense. And am I right in assuming that that automatic method works well for simple scans, you know, maybe something that's not overly intricate and complicated with the surface detail, in those more complicated models require a little bit more hand-holding by the user?
So yeah, so when it comes to the automatic surface, I usually like to clean it up a little bit more just because you're going to be putting a lot of patches and you want it to have to think a little bit less. So I might be filling in some of the holes and things like that and then doing the automatic surface. But I might have maybe like made some circles before I filled in those holes to know where those holes were and things like that.
Okay. All right, good to know. In terms of this whole industry, it's still relatively fresh, relatively new, and as we've already talked about, the technology's marched on pretty quickly, and the price point and what you get for that money is just every day sort of improving. If we could look into the future, maybe if you gaze into your crystal ball, you know, knowing what you know about 3D scanning at this point, where do you sort of see the technology in maybe a shorter term? I'm talking sort of maybe 3 to 5 years. And then, you know, maybe on a longer term, maybe around the 10-year mark, what are we expecting as enthusiasts to have access to?
Yeah, that's a good question. So just given the experience that I've had with Creaform and Peel, I've already seen a few scanners go down in price by quite a bit because new technology has come in. And the new technology that comes in is always kind of like faster and able to scan things that we didn't think we could scan before, getting more detail. So yeah, I think even with the new Handy Scan Max that just came out, I think last year with Creaform, that one can scan like an entire Jeep, like the exterior within seconds. That was like we were over at SEMA last year, which I think every year Creaform and Peel is at SEMA, and we had a Jeep, and I was able to scan the whole thing like really, really quick. So that one blew my mind when I saw that one.
If we could just give sort of, obviously those who haven't done this before have really got no concept. If we were to compare that product you've just talked about with the likes of the Peel 3, how long would scanning that same vehicle take with the Peel 3?
Right. So with scanning the Peel 3, you would have to probably figure out where you need to put the targets first. So you'd put a few targets here and there. And even if you need them later on, you can always add them on as you go too. So that's not that much of a problem. But once you've put on the stickers, you can probably scan it, I would say maybe, I'm not sure, 30 minutes or so, maybe something like that.
Yeah, but substantially longer than seconds.
Right.
So as you'd expect, lower price point, faster scanning, and more detail. That's basically what we've got in store.
Exactly, yeah.
All right, Gabrielle, I think we'll move towards wrapping this up, and we've got the same 3 questions we ask all of our guests. The first of those is, what's next in the future for you, Creaform, and Peel 3D?
Okay, yeah, for me, Well, I actually just joined Peel 3D a few months ago. So the future is Peel for me, and I'm really excited about it. I've been having a great time going to different trade shows like Peel Garage and different things with the Peel team. I've even helped make a marketing video. I mean, this is the first podcast I've ever done, so this is exciting already as it is. But yeah, I'm having a great time being a sales applications engineer and just talking about our product to anybody that'll listen about it because it's a really fun discussion for me. And then as far as Peel goes, we're always innovating. Creaform is a very innovative company, so I'm sure there's always something new coming around the corner, whether that's just a new tool and software updates, or maybe someday a Peel 4, but I wouldn't know when that would be because R&D keeps their doors locked pretty tight, so I'm not sure on that one.
That's totally fair as well. All right, next question. Is there any advice you'd give to a younger version of yourself to help reach where you are today in your career faster? Now, this is normally a question that's obviously angled towards those that are in the automotive industry. We've already clarified that you're not, but that's absolutely fine. But I mean, just given your background, the mechanical engineering degree in particular, as I mentioned, probably more than half of our guests have gone down that same path, and it can lead in so many directions, and obviously often into the automotive industry itself. So yeah, I'm just interested, any advice you'd give there?
I think I would just say to continue working as hard as you're working. I've always been pretty continuously motivated person to just keep on going. And I think also probably one of the more important things to keep track of is like how happy you actually are to make sure that you're doing something that you're actually enjoying. Other than the part where I was studying mechanical engineering, that part was not very happy for me because that was a lot of work, a lot of studying all the time. Same as nuclear power. That was a lot of studying. That was the most difficult thing I've ever done. But once you like realize how much you can push yourself and you continue to push yourself at that level, you can go really far. But I think probably the more important thing is to make sure that you're happy while you're doing those things, because otherwise it's not all flowers, but that's what you want it to be. You want it to be awesome.
Yeah, I think this is a comment that comes up multiple times with our guests is, if you're doing something that you're genuinely passionate about, the old saying, if you do what you love, you'll never work a day in your life. And as I've said multiple times as well, there's still going to be hard days, but hopefully those hard days are going to be fewer and further apart than your friends and colleagues who are, working in, potentially a dead-end job that they're absolutely hating, but they're kind of stuck in the rat race because they need the paycheck every week, which obviously kind of makes it a bit difficult. So yeah, definitely if you can find something that you are genuinely passionate about and make a career out of that, all power to you. You probably end up in the sort of maybe limited 5 to 10% of people that have actually managed to do that.
Yeah.
Right, last question for today, Gabrielle. If people want to follow you and see what you're up to, how they best to do so. So this could be, websites, social media accounts, etc.
Sure, yeah. As far as Peel goes, we have an Instagram account that's peel.3d. Then we have Facebook, that one's Peel3D. They're all different for some reason. We even have Sketchfab for anybody that's out there enjoying their 3D printers. You can go on Sketchfab and look at our files that we've scanned and put up online, and that's peel-3d.com. That's our tag there. But yeah, we're always at SEMA. We are always going to be doing our Peel garages, which is kind of like around the country of the United States. We'll set up shop in a few different places, kind of like a welcome everybody kind of thing. And we'll just show you how our scanners, would be used in your auto body shop. And you can even come if you already have a scanner to ask questions as well for those. And I think those are the main things that we're up to.
Okay, perfect. Well, we'll put the accounts in the show notes to make it easy for people to find. And I think at this stage, we're planning on a trip to SEMA at the end of this year. So we'll make sure that we look you up and come and say hi in person and see what's new in the world of Peel 3D.
Perfect. Yeah, I'll see you there.
Look, thanks heaps for your time today, Gabrielle. It's been great to get a little bit more insight into these products and how they're developing as well as what they can be used for. And certainly it is really exciting seeing how quickly it's developing. So we look forward to testing out our Peel 3 and also seeing what comes out in the future. Thanks again.
Thank you so much.
If you enjoyed this episode of Tuned In with Gabrielle, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Red Bull Guru from the US, who has said, amazing long form pods, but surprisingly fantastic short clip episodes as well. The new trend of constant small pods hasn't been enjoyable on a single podcast besides this one. I can't remember a time I've been so happy and entertained while truly learning. Great guests and a fantastic host. Well, thanks for the kind words, and if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview, and before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.